Okay, this is the position where we have outer ear, over window sometimes called, and then this is about 40 millimeter. As you can see here, 50 hertz reaches over here, and 1.6 kilohertz only reaches over here. So the frequency, depending on frequency, the waves propagate and cochlear system is different. Okay, that makes some interesting auditory sensation you can experience today. Okay, now if you see over here, this is a decibel scale. This is a micropascal scale. As you can see here, can you count the number of zeros over here? It's very hard, right? If you try to draw this scale linearly, then you can immediately see that this is impossible. Okay, but in decibel scale, this is just a 140. And this is 0, and this is a 60. And between 70 and 140 is 140 is just twice bigger than 70, but that is completely wrong. That is completely wrong, because decibel scale, and you can see later, is not linear scale, that is log scale. Okay, so when I have, and when he has the same sound, 60 decibel, that does not produce 120 decibel at all. Okay, I will go some detail about how to calculate the sound pressure in decibel scale when we have one more, two more, three more different sound. Okay? So roughly say, very lousy, big sound is about over 120 decibel. I hope you do not test this sound level. Okay, when you have a very heavy truck pass by, that it would be more than 90 decibel. And from quiet library, I would say 35 hertz. And this lecture hall, what we measure, 37 decibel, right? So that is a sort of reference decibel scale you can have. Okay. Okay, decibel scale. This auditory demonstration is obtained from Acoustics Society of America. They had some CD, and we used that to make our demonstration.
The decibel scale. Broadband noise is reduced in 10 steps of 6 decibels. Demonstrations are repeated once.
This is not my voice. Six decibel difference. Okay, you can clearly distinguish the tone you hear at the fourth and second and third, right? And that is a 6 decibel scale difference, right? That is 6 decibel difference. Okay, let us have 3 dB a different reduction case.
Broadband noise is reduced in 15 steps of 3 decibels.
Okay, that is 3 dB difference. You can sense it, but compared with the 6 decibel difference, 3 dB difference is very marginal, right? Okay, but later on you will find that 3 dB difference is in linear scale is twice smaller than, I mean, 1/2 of the magnitude. So when you do the noise reduction, you may say, hey, I reduce noise 1/2 of the noise we have by half. I reduce the noise by half. This is a lot. But your supervisor will say, I cannot see the great difference, right? A 6 decibel scale reduction is a huge, appreciable level. Okay, what about the 1 dB reduction? Let's see.
Broadband noise is reduced in 20 steps of 1 decibel.
We cannot hear the difference. Okay. So, well, at least we can say by having this experiment, oh, decibel scale is a really complicated scale. Okay? Right. Okay. Next. Okay, let me. Okay, then as I said, the frequency of the sound pressure is also another important parameter. Let's see. Okay, just a second. What this demonstration will do for you is I will ask you to count the number of steps, okay? Okay, and this demonstration will produce the tone, actually beep, like a beep, 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 112, 125 hertz, 250, 1 kilohertz, and so on, with different SPL, sound pressure level. And for example, when you hear 125, boom, 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 and you counted how many counts you can hear, okay? And you wrote down on your note. That will give you your ear's sensitivity. Okay, I hope you got a similar curve. Maybe if you have a very interesting curve, then that means you have to go hospital, okay? But I must say, this experiment is not accurate. It's not accurate, okay? We just want to see our auditory system's sensation to frequency, okay? Okay.
You will now hear tones at several frequencies presented in 10 decreasing steps of 5 decibels.
10.
Count the number of steps you hear at each frequency. Frequency staircases are presented twice.